Hello guys, you're welcome to my channel. This will be the first lecture for the WAEC and JAMB series. If you are watching this video, just understand that today you are going to get the real meaning of vector and scalar, and you are set to understand every concept behind this topic. When you talk about a scalar quantity can uniquely be defined with just one figure. And that's why we said they are quantities with magnitude but no direction. But when you talk about a vector quantity, they are quantity that you cannot describe with one figure. That's why we said they are quantity that has magnitude and direction. Example of quantity that you can uniquely define with one figure, which we regard as a scalar quantity, are mass, length, temperature, current, luminous intensity, magnetic flux, etc. And when you talk about those quantities that you can regard as a vector quantity which you cannot describe with one figure that requires magnitude and directions, examples include force, momentum, torque, moment, acceleration, displacement, position, etc. They are all examples of a vector quantity. Now, when you talk about a vector quantity, if I have A to be a vector quantity, let's take for instance that this is a vector quantity. How are you going to know that this particular quantity is a vector quantity if you see it without mentioning the name? So, when they are writing a vector quantity like this, there is always an arrow on it. If you don't find an arrow on it, like in the textbooks, it's going to be written boldly. When you see the A boldly written like this, you should know that this is a vector quantity. Now, let's talk about the representation of a vector. How do you represent a vector? If you want to represent a vector, let's take for instance that I'm talking about position now. What is position? Position is the distance between two perpendicular lines. That is, if this is a straight line and here is another line, these two lines, provided that they make an angle 90 degrees with each other, it shows that they are perpendicular. So position is the distance between these 2 points. So if this is vector A, I can talk about this vector in the direction of X. I can talk about this vector in the direction of Y. I can also talk about this vector in the direction of Z. So if I'm to represent this single vector A, I can't just represent it as A. I will represent it as A equal AX plus AY plus AZ. So this means in the X direction, in the Y direction, and in the Z direction. So some materials can have it as A in the I direction plus A in the J direction plus A in the K direction. Whichever one, we are still talking about a vector quantity. Now, because a vector quantity cannot be represented in one word, because it has magnitude and direction. Hence, if we are going to add or subtract a vector quantity, we cannot just add like normal algebraic word addition. Like if I have 2 cups of tea and I have 3 cups of tea, if I add it together, I'm going to have 5 cups of tea. But the case of vector is quite different from that. We are going to start by looking at the magnitude of a vector. How can you get the magnitude of a given vector? For instance, if the question says find the magnitude of A. So for me to get the magnitude of A, I know that A itself is equals to what? AX plus AY plus AZ. Hence, I will have this sign to represent the magnitude of vector A, in which is going to be the square root of AX square plus AY square plus AZ square. So this, whatever result I have here, will be the magnitude of A. And magnitude simply means what? Size. When they say magnitude, we are talking about what? Size. Now, let us now talk about the addition. The addition of a vector. The addition of vectors. Now, for us to add vector together, I would like you to understand something. If I'm given a vector, let's say this is a vector, and the vector is of magnitude A. This vector will have two reference points. How many reference points? Two reference points. It's going to have the initial point, and the terminal point. The terminal point. These are the two reference points of a vector. Now, what does this have to do with addition of a vector? For you to know if you are going to add two vectors together, the two vectors you are to add together must satisfy this condition. For a vector to add a vector with another vector, the initial point of one must coincide with the terminal point of the other. So if you are going to add two vectors together, terminal point of one must coincide with initial point of the other. What are we saying in essence? Let's consider this diagram. If this is a point and this is another point here, and I have another point here. So if I have this as vector A and I have this as vector B. Now this point here that I'm going to call vector C will be the resultant of A and B. So am I going to add A and B together to get C, or I'm going to subtract A from B to get C? Now I have to check where is the terminal point of A. If I call this point A and I call this point B and this is point C, the terminal point of A happens to be at point B because that's where the arrow is pointing towards. The initial point of B happens to be at the same point B. This to tell you that what? A and B, they coincide. Hence, for me to get the value of C is going to be A plus B. Are we getting this now? So, if we are getting this, let's take a look at this one that we have here. If this is B and this is A. So if you look at this now, here will be the terminal point of, will be the resultant rather. It's going to be the resultant of A and B. But we don't know, are we going to subtract A and B to get what? To get C? We don't know. So we check. The terminal point of A is at this point B here. Here is the terminal point of A. And the terminal point of B also happens to be here. Now you see that terminal point and terminal point coincides. So if terminal point and terminal point coincides, the value of C is said to be A minus B, or B minus A, depend on the one that is greater. So to play safe, we'll put the absolute value. So this to tell you that if you are going to add two vectors together, you must check the terminal point and the initial point. If they coincide, then you are to add. If they don't, maybe terminal point coincides with terminal point or initial point coincides with initial point, it means you are going to take their difference. Now, what does it mean for terminal point and initial point to coincide? When terminal point and the initial point coincides, it means the two vectors are facing the same direction. But when terminal point and terminal point, or initial point and initial point coincides, it shows that the vector are facing different direction. Now look, if this is a vector that is facing this direction, you will see that its initial point is this point and its terminal point is this point. If this is vector A and this is another vector B that also face this same direction, you can see this is its own terminal point and this is its own initial point. So you can see that terminal point of A will serve to meet with initial point of B. And that's why we said when two vectors faces the same direction, what you need to do is to add them together. So let's proceed by looking at another concept on this particular topic. So we are going to be looking at what we call resolution of a vector. Resolution of a vector. When you talk about resolution of a vector, what are we talking about exactly? Now, if you look at this particular marker I have at hand, it's impossible for this marker to stand on air without support. You can see if I try to let it stand on air, you see it falls down. Now let's say this is this marker here. If I have this marker here, you see now, you already know that this marker cannot stand like this on air. But with a support of this horizontal component and the support of the vertical component, these are the two things that will make this particular pen to stand on its own. So you see it's resting on two things, vertical and horizontal. Now let's take for instance that it's making an angle theta with the horizontal. Let's say this particular length of the pen is R. So if the length of the pen is R, then this is going to be its vertical component, and here will be its horizontal component. But we know the value of R and we know the angle that it's made with the horizontal. But what exactly is the value of this vertical component and the value of this horizontal component? Now, you can see this as a right angle triangle. When you have a right angle triangle and you have two sides to be unknown, but you know the angle and you know the third side of the triangle, you can apply the trigonometric ratio. By applying trigonometric ratio into this particular question, I will have that the sine of angle theta is equal to opposite over hypotenuse. Recall that anywhere the angle is facing is known as the opposite, and anywhere the angle 90 face is known as the hypotenuse. So the opposite in this case will be RY and the hypotenuse will be R, which is the main vector that we are talking about. So if I cross multiply, I will have that R sine of theta is equal to R sub Y. This particular R sine theta happens to be the value of the vertical component of R when it make an angle theta with the horizontal. Now, how can we then get the value for the horizontal component of R? Good. We said since the horizontal component is the adjacent and R happens to be the what? Hypotenuse. So we can say the cosine of theta is equals to adjacent over hypotenuse. And our adjacent is going to be what? Rx. Our hypotenuse is R. So when you cross multiply, I will then have R cos of theta to equal what? R sub x. This value is the value for the vertical component and this value is the value for the horizontal component. Now, what are we then saying when we said resolution of a vector? Resolution of a vector simply means that you should break the vector into components. Components such as the vertical component and the horizontal component. Now, I would like to tell you in this video that you don't cram how to break what? A vector into its component. You know, for this particular vector we have here, we have gotten the vertical component to be the vector sine of its angle that it made with the horizontal. And we have gotten the horizontal component to be the vector cos of the angle that it made with the horizontal. But what if this particular vector made an angle with the vertical instead of the horizontal? How are we then going to resolute it? Fine, let's quickly look at that. Let's take for instance that when R wants to make an angle, you know, it's going to have support vertically and it's going to have support horizontally. So if this is the support horizontally, so here will be angle 90. Now, instead of making an angle with this horizontal, it's now having an angle with the vertical. Then we have to resolute the vector R to get the vertical component and the horizontal component. We also do what? Apply the trigonometric ratio. For us to get the vertical component, since this place is the opposite and here is the hypotenuse, here will be adjacent. So I'm going to use cosine of theta to equal adjacent over hypotenuse. So I will then have that Ry divided by R. So if I cross multiply, I'm going to have R cos of theta to equal Ry. So this is now the vertical component. For this horizontal component now, I will then have that sine of theta equal opposite over hypotenuse, and that will be Rx divided by R. So if I cross multiply, I then have that R sine of theta equal Rx. So this is equation 4. So you can see now that the more immediately the angle interchanged, what happens to the ratios also? There is a change in the ratio. You know, before R cos of theta happens to be our horizontal component. It will be horizontal component if the angle is made with the horizontal line. But it's going to be the vertical component if the angle is made with the vertical. So don't let us cram, but we should understand this. Now, I haven't said this. Now, if I have large numbers of vectors, like I'm having 4 vectors, 5 vectors, or 2 vectors. For instance, a typical example you can easily understand is if you are in need of torchlight and you're also in need of MP3. Now, it means you are needing 2 gadgets. You have to get MP3 and at the same time you need to get what? Torchlight. But if you can get a device, instead of you getting 2 like that, you prefer to get a device that is going to have torchlight and also MP3. You prefer to get that. But as a matter of fact, you don't really know what that is called in physics. Now let us quickly look at what we call resultant, so that we are going to understand whenever we need what? Large number of devices or anything, and we are able to equivalent those things with just one figure, what is it called? So let's quickly look at what we call resultant and of a vector, resultant of a vector. The resultant of vector. What is resultant of a vector? The resultant of a vector is a single vector that will have the same effect as two or more vectors acting at a point. The resultant of a vector is a single vector that will have the same effect as two or more vectors acting at a point. Let's take, for instance, if I have two vectors, u and v. If this is a vector u, and I have another vector v. If these two vectors are perpendicular to each other, if u is perpendicular to v, we can get the what? We can easily get the resultant for u and v. So if I have this, I have this. If this is v and this is u, so instead of me having these two vectors, I can just have what? A single vector that will have the same effect as u and v, and that is vector r, called resultant. So let's say this vector makes its direction with the vertical. So if I have this now, I have this vertical component and I have this horizontal component. So here is equivalent to u and here is equivalent to v. Now I can decide to consider right angle triangle OAB, or I decide to consider right angle triangle OCB. So this particular angle here is alternate to the one here. Now let us now consider right angle triangle OAB. So I have this. This is angle theta, and this is the resultant. Here is angle 90, here is v, and here is vector u. Now, I know these two vectors to be perpendicular to each other, hence the magnitude is known. Hence, I can find this resultant by saying r square equal u square plus v square, the Pythagoras theorem. Hence, r is equal to the square root of u square plus v square. Whatever result I have here will be the resultant of these two vectors. Now, another question that you might find here is, what is the direction of the resultant? So we can also get the direction of the resultant by saying that, by looking for this particular angle here. Now, if I have this and I have this, how can I get this particular angle here? So what relates opposite and adjacent together is called tan. So I have that tan of theta is toa, which is opposite over adjacent. Remember, anywhere angle face is called the opposite of that angle, and the other side will be adjacent. Where angle 90 fails will be hypotenuse. So this will be v divided by u. Hence, the tan of theta will become v over u. So theta will then become the arctan of v over u. Please, this is not pronounced as tan inverse. It is pronounced as arctan, because if you say it's tan inverse is 1 over tan theta, and that is what? Cot theta. So this is not the same thing as that. When you have logarithm of a number, let's take for instance that logarithm of a number 10 in base 10, the result is going to be 1. So if I said I want to know the number whose logarithm in base 10 give us 1, all I need to do is to take the anti-log of 1. So I will not say the inverse log of 1. So I'm going to say the anti-log of 1. So the same thing goes to this. If tan of a certain angle give us what? V over u. Then how are we going to get that angle whose tan is V over U? So we need to take what? The arctan of what? V over U to get the angle. So whatever result you have here will serve as the resultant of the vector. Now let's take for instance that this angle is 53 degrees, for example. If this angle is 53 degrees, we are going to draw a cardinal point. Remember, it can take any value. So this is north, south, then east and west. So you know, from here to this place is 90 degrees, down to this place 180, 270, then 360 when it's complete a circle. Now you should understand that we read angle from north or from what? South. So if we are reading this now, 53 degrees will fall somewhere here, then we have this. Hence, the resultant direction is going to be north 53 degrees east. So that is how to determine the direction of a resultant. So we are able to look at how to get the resultant of two vectors. Now, what if the vectors are more than 2? What if the vectors are more than 2? Take for instance, you are having like 4 vectors or 5 vectors or more than. How can you get their resultant? To get their resultant is as simple as what you know. Remember, we have covered the resolution of a vector. Now, we are going to consider 4 vectors and let's see how we can get their resultant. So resultant of 4 vectors. Resultant of 4 vectors. So let's take for instance, let's take the theoretical statement down. Let's say given that vectors f1, f2, f3 and f4 makes an angle theta 1, theta 2, theta 3 and theta 4 respectively with the horizontal as shown below. So if I have 4 vectors that makes an angle theta 1, theta 2 and theta 3, theta 4 with the horizontal as shown in this diagram we are about to draw. So if I have this and I have this, so let's say this is a vector and I have another vector here. So let's say this is vector f1 and it makes an angle theta 1 with the horizontal. This is vector f2 and we have another angle theta 2. This is f3 and I have an angle theta 3, and here is f4 and this is an angle theta 4. Remember, this particular side here happens to be the positive side of x. Here will be the negative side of y, and here will be the negative side of x, while here is the positive sides of y. Now, if we have this, how can we then find a single vector that will represent these 4 vectors? All we need to do first is to open a table to make the work easier and to avoid error. We have a table where we have the x components, and the y components. Now, for each vector, we are going to break them into components. Let's say for vector f1. So if you look at vector f1, it's like this. So this is F1 and this is theta 1. So it's having a vertical component, which is f sub y, and horizontal component, which is f sub x. Remember, when a vector makes what? An angle theta with the horizontal, like we said here, this is now like the diagram that we are seeing here. So it means that our result for the vertical component is going to be arrow sine of theta. So we are going to have, for the y component, we are going to have f1 sine theta 1. And for the horizontal component, we are going to have f1 cos theta 1. So for the second one, which is f2, we are going to have the vertical component to be f2 sine theta 2, and the horizontal component will now be negative because the horizontal component faces what? The negative axis. So we are going to have negative f2 cos theta 2. And for f3, the vertical component of f3 is pointing towards the negative axis, so it's going to be negative f3 sine theta 3. And for the horizontal component of f3 also, still on the negative axis of x, so we have negative f3 cos theta 3. So if you now look at f4, the vertical component of f4 points towards the negative axis. So we have negative f4 sine theta 4, and the horizontal component becomes positive. So we have f4 cos theta 4. Hence, what we need to do now is to have the summation of the x-axis, that is the summation of the x component and the summation of the y component. So when we get the summation of the x component, compare it to the right angle triangle. So here will be an angle theta. So this place will be the summation of the y-axis, and here will be the summation of the x-axis. So we then have to look for the resultant. Hence, the resultant r square is going to be summation of x square plus the summation of y square. So we can then have that r is equal to the square root of the summation of x all square plus the summation of y all square. Whatever results you have here is the resultant of the four vectors. So now let's quickly look at a case whereby we are asked to look for resultant, but as a matter of fact, the vectors never being perpendicular to each other, and they are just two in number, they are not up to 4 or 3, and we are asked to look for their resultant. Let's take for instance that those two vectors, they make an angle 60 degrees with each other. How are you then going to find their resultant? Because you have only been taught how to find the resultant when the two vectors are perpendicular to each other, and you have been taught how to find the vectors when they are more than what? When they are more than 2. But you don't know how to get the value of the vector should in case they are not perpendicular and they are not up to 4 or 3. They are just 2 in number, but they are not perpendicular. How can you get their result for the resultant and their direction? Now, it's very simple. We are going to consider a law known as the Parallelogram Law of Vector. The Parallelogram Law of Vector. What does this law state? The Parallelogram Law of Vector states that, pay attention to this law. The law states that given two vectors let's go by U and V. You can decide to go by A and B, no qualms. So I said U and V, given two vectors U and V that are moving simultaneously, they can be represented by the adjacent sides of the parallelogram in magnitude and direction, while their resultant can be represented in magnitude and direction by the diagonal line of the parallelogram drawn from a point. So this is what the parallelogram law of vector states. You might be asked in the exam that you should state the parallelogram law of vector. You should be able to state this. The law is very simple, just understand it. Now let us look at the law mathematically. The law states that if you are given two vectors U and V that are moving simultaneously, they can be represented in magnitude and direction by the adjacent sides of the parallelogram, and their resultants can also be represented in magnitude and direction by the diagonal line of the parallelogram. Now let us see how to determine the value using the parallelogram law of vector. So let's take, for instance, that I'm blessed with a parallelogram. So if I have a parallelogram like this, so if this is a parallelogram, so these are the adjacent sides of the parallelogram. So let's take, for instance, that we have vector U represented with these adjacent sides. Here will also be U. And then we have vector V represented with these adjacent sides of the parallelogram. Now, they both makes an angle theta whose value is unknown. Now, their resultant is said to be the diagonal line drawn from a point. So, this is the resultant of the two vectors. Now, this resultant is said to divide this angle into two. So here, angle in this place will be half theta, and the one here will also be half theta. Remember, this one is said to be half theta as well. So here is alternates to this place, and that's the reason why here is half theta also. So if this place is half theta and here is half theta, the value of this angle here will be 180 minus theta. So if this is A and this is B, Y here is C and here is what? D. So I now have a triangle. I have a triangle DCB. So if you look at this triangle DCB, I'm having this side and this side, and I assume that I know this side because 180 minus theta should give me the value of this angle. But I'm looking for these sides, which is the resultant. Now I can apply the cosine rule because here is not a right angle triangle, so I cannot apply the Pythagoras theorem. And I'm having just a single angle, not two angles, so I can't use the sine rule. So I'm going to use the cosine rule. So using the cosine rule. So I'll have r square to equal what? U square plus v square minus 2uv cos of 180 minus theta. So if this angle happens to be an acute angle, so this is an acute angle. An acute angle are those angles greater than 60 degrees but less than 90 degrees. So if this is an acute angle, it shows that cos will fall in the second quadrant. So if cos falls to the second quadrant, we are going to have that cos of 180 minus theta equal negative cos of theta. So we can now slot this into this equation. Then we have r square to equal u square plus v square minus 2uv, then negative cos of theta. Negative 2uv times negative cos of theta will become positive. So I will then have r square to equal u square plus v square plus 2uv cos of theta. So the resultant will become the square root of u square plus v square plus 2uv cos of theta. Whatever value I have here will be for the resultant. So you can use this when the two vectors are not perpendicular to each other and they are just two in number in a certain angle to each other. Now the question now is, how can we then get the direction of this vector? So to get the direction of this vector, I'm going to reconstruct this triangle by drawing this side down. So if I have this, I'm going to have this place also extended. So if I have this side, let me call this place point E. Now this particular angle here is corresponding to this angle here. So here is an angle theta also. Now I have u, but I don't know this vertical component and this horizontal component. That is never a problem. So all I will do is to resolute u. If I resolute u in respect of this angle, this vertical component will become u sine of theta, and this horizontal component will become u cos of theta. So if I now consider the right angle triangle, if I consider right angle triangle DEB, so I'm considering this right angle triangle now. Let's say the angle is beta. So if this angle is now angle beta, so I can now say the tan of beta, which happens to be the direction of r, is now equal to our opposite, and that is BE over adjacent, which is DE. And this is going to be BE divided by DE is the sum of what? DC and CE. So we have DC plus CE. Hence, the tan of beta is equals to BE, which is u sine of theta divided by the horizontal DC is going to be V, then plus CE, which is u cos of theta. So we can then say the value of beta. So beta is going to be the arctan of u sine of theta divided by V plus u cos of theta. So whatever value I have here is the direction of the resultant. Okay, let's quickly look at another aspect of this course, in which most teachers don't focus and most students also don't usually focus on. And what is that concept? The concept of equilibrant. So we have talked about the resultant of a vector. Let's talk about the equilibrant of a vector also. So equilibrant of vector. When you talk about the equilibrant of a vector, so we said, resultant of a vector is a single vector that will have the same effect as two or more vectors acting at a point. So we are to look at what is an equilibrant of a vector now. Equilibrant of a vector. The equilibrant of a vector is a single vector that will balance the system of two or that will balance the system of three, this should be three, the system of three or more vectors acting at a point. Now, you will ask me, why not 2? Because resultant is from 2 upward. Why not 2? Why from 3 upward? Equilibrant of a vector will only occur from 3 vectors upward. Why? Because 2 vectors cannot make a closed system. When you have 2 vectors, it can make a closed system, and that is why we said it's from 3 upward. Now, how are you going to calculate for equilibrant of a vector? It's very simple. If you are given 3 vectors, 4 vectors or more, and you are asked to look for their equilibrant, to get the equilibrant of a vector, it's a very simple thing. You just calculate for the resultant of the vectors and also calculate for the direction of the resultant. But understand that resultant is equal in magnitude with equilibrant, but opposite in direction. For instance, if your resultant is 5 in magnitude, then your equilibrant is also 5 in magnitude. Then if your resultant direction is towards east, you should understand that your equilibrant direction will be towards west. If your resultant direction is north of east, your equilibrant direction will be south of west. So they are equal in magnitude but opposite in direction. Thank you. And we are going to solve more questions on this particular topic from the 2 said exam, the JAMB and the WAEC. Thank you.